This is Elon Musk. Welcome to AllStuff.ai. Just kidding. This is Rick Bentley. That was a deepfake video, and we're going to talk about it on AllStuff.ai. Hey, everybody. Oh, my goodness. Look at the AllThings pattern on that shirt. I'm going to change shirts here. I'll be right back. Welcome, everybody, to AllStuff.ai. We're going to be talking about artificial intelligence, what it is, what you can do with it, how to make it. My name is Rick Bentley. I first started working in machine learning, artificial intelligence in the 1990s at a company called Sensory, which I did right after grad school at Berkeley, where I was physics and engineering. I'm founder of both Cloud Structure, which does computer vision, including face recognition, etc., in the cloud for video surveillance, and HydroHash, which is crypto mining at medium scale so far. We're burning a megawatt of power onto computational engines to do a lot of math real fast. And so I know a bit about AI, how to build it, how to make it, how to run it, and been around it for a long time. So let's dig in. I'm going to be the little guy in the window here. I'm not going to go full screen on you. And I want to talk about first the definition of AI, artificial intelligence. Let's go ahead and ask Grok. I asked Grok here to define AI. AI is the development of computer systems that are able to perform tasks that would normally require human intelligence, such as understanding natural language, recognizing images, and making decisions. It's like giving a computer a brain and teaching it to think and learn like a human, but with the added benefit of not needing coffee breaks or vacation time. Grok's very colloquial. If you don't know Grok, it's on x.com, formerly Twitter. There's no waiting list like ChatGPT, etc. to get in. It seems to be at least as good, and it's trained up to date. ChatGPT runs 6 months or a year or something behind on training models. You can get recent events, etc., and breakthroughs and news off of Grok. So in any case, this is a good definition. I would argue a slightly different definition. I would argue you don't actually need a computer system for AI. And let's explain why here. So when was the term AI first used? And AI was first used probably longer ago than you think. 1955. So we're a half century back from when AI was first used, right? When was the IBM PC released? So AI was coined a half century ago, and the IBM PC was released in 1981. So a quarter century ago, 25 years ago. And I don't know if people remember, but you really couldn't do much with a PC. It was a command line interface, they call it nowadays. Back then it was DOS, Disk Operating System Interface. So show me a computer DOS interface. All right. This should show us a few pictures here. Google Images is probably actually a little bit faster than this. I don't like how it types things out here. I've tried shutting it off and it doesn't want to do it, but this was your interface back then, right? If you wanted to try and build a computer to play chess, one, it wasn't really good at it, and two, you had to type in, A2 to A4 kind of thing. It would tell you if it was a legal move or not. All right. So let me show you another example of what I will argue is AI. This is the humble Mercury switch thermostat. Here's a close-up picture. So, what the heck is this? First of all, what's a Mercury switch? This is a Mercury switch over here on the right. And you can see there's two contacts, two wires, and there's a ball of mercury. And when this is tilted to the left, the ball of mercury is not connecting those two leads. And when you turn this cylinder to the right, the gravity would pull this ball of mercury down and would connect those two leads. Mercury is a metal. It's liquid at room temperature. It is conductive, and so it'll connect those two leads. So back to our humble Mercury switch thermostat. Here's our Mercury switch. It's all dusty. There's two leads at the end. You can kind of make out the ball of mercury in there. So right now, this switch is connecting those two leads. And this is metal in this spring here. And it might be a sandwich of two different types of metals that have different coefficients of thermal expansion, or it could just be one. But the idea here is when it heats up, it expands. So the coil, when this heats up, gets bigger. And so this whole ball on top kind of shifts to the right and now is tilting down to the right, the ball Mercury slides over and the leads are no longer connected. This is, to some extent, artificial intelligence. It has two thoughts. The first thought is, it's not warm enough in here, I'm going to turn on the heat. And the second thought is, it is warm enough in here, I'm going to turn off the heat. And it's done with no computer. There is using electricity here, but people say, oh, this isn't AI, this doesn't count. Okay, let's go back to a caveman and tell him, hey, you like having fire in your cave? Fire is pretty cool. Okay, well, how about this? What if I brought this device into your cave and it would keep your cave at the same temperature all the time? If it was starting to get cold, it would add more wood. And if it was getting too warm in here, it would add less wood. And if you're on your way out and didn't want to use up your wood because you're going to be gone all day, you could set it back and so it would use less wood. You'd be like, wizard, that is magic. That's nothing short of magic, right? Well, we're spoiled today. Today, this probably most people would say is not AI, but just look at the words. Words have meaning, right? It is artificial intelligence and that it has two intelligent thoughts. Okay. Now, back to Grok here, which I think most people would agree is artificial intelligence, right? It can define AI for us. It can do a lot of really interesting things. This is a large language model AI. It passes what would be called the Turing test. A scientist named Turing proposed a test that if you could communicate with an interface and you couldn't tell if it was a human or a computer, then it would be, not necessarily alive, but it would be passing at least the Turing test, right? So Grok certainly does that, and things have for a while now. Chess computers now are better than humans at playing chess. Grandmasters will check the engine to see what the exact perfect move would have been then and compare that to what they did, right? When I was growing up, people were struggling to make a computer that could play decent chess or passable chess. And then they were entering them into tournaments, and away you go. I think we're going to see this again and again. Just like we have chess computers in tournaments, and they win so well now, it's now cheating to use a computer to help you with chess. We're going to see all sorts of things with doctors and lawyers and people writing lease agreements in here without law licenses and things like that. Okay, so let's talk about some more modern AI stuff. I mentioned before, I'm CEO of CloudStructure and HydraHash. I founded both companies, and they are both highly computational. So just pick up a picture here. This is, you can count them here, 1, 2, 3, 4, 5, 6, 7 RTX 3090 NVIDIA GPUs. They're a little more powerful than the ones that they want you to use in data centers that they charge more money for. These are the consumer version graphics cards, and they're actually more powerful than the more expensive ones they want you to use in data centers. So being highly efficient, CloudStructure uses these for the way it does object detection and face recognition and things like that. So you wonder why you can't see them here. These tubes on top, these are liquid cooled. They generate a lot of heat. They'll overheat pretty quickly if you run them flat out all the time. And we do, because we're uploading videos all the time. And the first thing we do with CloudStructure is we make sure all the objects in the image are detected, backpack, car, face, and things we're going to recognize, like faces, are recognized. So there's a difference between face detection and face recognition. Face detection is, hey, we detected a face. Face recognition is, I recognize that guy. That's Rick, or that's Dave, or that's Greg, or whomever. So license plate detection would be a detected license plate recognition, license plate reading would be it's California ABC 123. Get it? And of course, recognition is way harder than detection. We're going to go through this podcast series and we're going to go over more and more discussions about what is AI and what isn't, but the real, not just the $1 million question or the $1 billion question or the $1 trillion question. And by the way, I think Elon Musk said today that you have to spend billions of dollars every year just to really be in the AI arms race right now with large language models. And I'm sure he's right because he's actually doing it. And it was more than $1 billion, by the way. We can pull the exact number later, but it's staggering how much money this stuff costs. But the question for humanity is, when does Skynet come online? So a lot of people talk about a general purpose AI, which can do just about anything. I think about in terms of Skynet, when is it not only self-aware, but when does it have the ability for us to no longer shut it off? Here's an example. Let me show you right here. So when can it stay persistent forever? So I can ask Grok here, give me the code for a website that asks for an email address to join a newsletter, right? And so Grok here is actually going to give us back the code that we could just copy and paste into a web server and a SMTP server for the email if we want to send a confirmation email and all that. And here it is typing it all out, right? And we know computer viruses can spread and they can even mutate to make themselves harder to detect. Keywords in them can be changed, their file name can be changed, etc. All their file dependencies, their paths and stuff can be changed so that they're harder to find or root out and detect and delete. So when does a general purpose AI come online and infect all of our major computers and phones and everything else, and we can't really shut it off without humanity going offline, right? That's a difficult question to answer. We haven't seen that yet. Will we see it in our lifetimes? I don't know. I'm sure there's people watching this podcast, like my son, who might see that in their lifetimes. People think podcasts are for incels and their 40-year-old virgins in their mother's basement. I'll have you know that I'm 55, and I won't comment on the rest of that statement. So will I see it in my lifetime? I don't think so. I don't think, if I have 30 years left, I don't think it's coming that quickly. I think we have this, I think a lot of you have seen this before. Let me just pull it up real quick. There's the hype, and then there's the actuality, right? And this is true for any new technology that comes out. Here it is. So we see this, that's the wrong one. Here it is. We see this all the time in places that we go, right? Let me see if I can just make this full screen for everyone real quick. That worked out okay. A little zooming in here. All right, so every new technology has some R&D, right? And then it hits some peak of inflated expectations. And we are probably there right now with AI. I mean, Cloud Structure is doing some absolutely amazing things with AI, but we're not building Skynet, right? And Facebook and X and Microsoft, who are spending many orders of magnitude more money than Cloud Structure is, are also not yet building Skynet. Afterwards, there comes some trough of disillusionment, and then there's a slope of enlightenment, and there's this plateau of productivity, right? And that's going to be true for any new technology. And I have a picture here of Hudson. He is one of me and my wife, Melissa's 24 cats. We are not intelligent for having that many cats. They keep showing up stray and pregnant, and we keep taking them in and getting them fixed as fast as we can. But this is Hudson. As you might gather from this picture, he is not our smartest cat. That would probably be Lotus. But whether it's Lotus or Hudson, there is no AI as capable as either of these cats yet. You cannot build a robot that will run around at night and catch mice. Certainly can't build one that can eat the mice and use that for energy to power itself. But just run around the house and catch mice and not attack humans, etc., is just a little bit too much for AI at this point. People talk about robots. I mean, I like the Cyberdyne Systems Model 101 from Terminator, right? Fantastic device that we may see in the future. Right now, Tesla's talking about making robots. Boston Dynamics, which Google bought while I was working there, it makes some amazing robots. You've probably seen them doing the gymnastic tricks and stuff. None of those robots can do the most basic of human tasks. For example, I can tell pretty much any human off the street who's never even seen my house before, go upstairs, collect all the dirty laundry, pull the sheets off the beds, wash it, dry it, put the clothes in the drawers, and remake the beds. There's no robot that is even close to doing that around. Even just going upstairs is too much for all but the most insanely expensive robots, right? For that level of autonomy to figure out that sort of stuff in context, there's no way. It's not here yet. My lifetime, maybe. My son's lifetime, probably. But that's just not here. We're still in the trough of disillusionment. So, or we will be in the trough of disillusionment. We're still at the peak of unrealistic expectations. So in any case, we're going to go over real life examples of AI, and we're going to be checking in to see how close we are with each episode. I'm going to try and cover the latest and greatest stuff to see, how close we are to Skynet coming online. This will be a little bit like the Sarah Connor Chronicles. Only had one season. Fan favorite though. If you're really into artificial intelligence stuff, check out the Sarah Connor Chronicles. Very, very fun series. They're trying to find Skynet before it is created, and they're looking at chess computers and traffic flow systems and everywhere they can find a place where Skynet might first show up. And that's what we're going to be doing here. We're going to be looking in and trying to figure out where Skynet's going to come online. I don't want to say this is kind of like, the Hunting Bigfoot series, right? At the end, they don't ever quite find Bigfoot. Maybe we'll find Skynet. Maybe by then it'll be too late. But I'm not telling anyone that we're going to find Skynet. We're going to be looking for Skynet. So thanks for tuning in. This will be an informal podcast series. I will be tangentially talking about Cloud Structure and Hydra Hash, but this is my personal podcast series. I'm going to be hosting the videos on X, YouTube, and Instagram. I'm not big on social media. I gave up Facebook completely a long time ago when they got really censor heavy in the last election cycle. I spend some time on X. I apologize in advance for anything I say that might offend people. I'm a staunch libertarian, if you will. So everyone, please do what you want. If you'd like to tune in, we'd love to have you. We'll post things on YouTube and Instagram as well, so that platform of your choice. And thanks, everyone. We'll have more of these coming out every week or two. And I'll bring in some guests. I know some people off the top of my head I think have a lot to add to a podcast series like this. And I'm not in my mom's basement. It's kind of more like my house's attic up here. It's my home office up in the mountains of Truckee, California. And we'll be moving around. We'll be looking at autopilots on cars and airplanes and just AI, where we find it, what it can and can't do. So I think it'll be fun. Have a great day.